next one. Bye. Welcome back everybody, and let's continue with our port scanner. So we managed to create a function that will convert the domain name into an IP address, and now we want to be able to specify multiple targets for our program to scan. Okay, so how we can do that? Well, it is rather easy. We're going to implement a little bit of changes down here at the bottom of our program. So here you will notice that we have the variable called IP address. Now it says enter target to scan. Well, we can simply just do something like this and specify to the user of this program that they can also enter multiple targets by typing target/s. And also we're going to specify to the user split multiple targets with comma. Okay, so simple as that. Let us make this a little bit better. But this is just the part where we prompt the user how they can specify multiple targets. Now we need to actually split these targets and scan each one of them one by one. So how can we do that? Well, first thing we're going to do is, so we don't get confused, we are going to rename this into targets variable. And then what we're going to do, we're going to delete this line for now. And we're going to specify if and then comma in targets. If there is comma in targets, logically that means that the user of this program specified multiple targets to scan. If there is not comma inside of the targets variable, that means that the user only specified one target to scan. So we're going to lead by that logic. So if comma is in targets, then for IP address, and we're going to call it simply just IP_add in targets, and we're going to call the function called split. And what this function does is basically it will split the string with the character that we specify inside of the brackets. So we want to split at every comma. If we split at every comma, that means we're going to split all of the IP addresses one by one. Therefore, we're specifying right here for IP address in targets.split, we want to scan each and every IP address. So scan port IP address, and then so we want to scan each and every target from this list. And in order to do that, we're going to create a function which is going to be called scan. Now I know we do have a scan port function, but we're going to use this function in order to scan one single port one by one. And we're going to call this scan function in order to scan each and every target and also convert the domain name into an IP address if needed. So all that this function will take as a parameter will be the IP address, which we get from this for loop right here. Okay? We also want to strip it from any unnecessary empty spaces in case there are some. And right now all we need to do is code this function. Let's go all the way up and call the scan function onto the target. So this will be one single target. And first we need to do is to get back the line that we deleted before, which is the conversion of the IP address. So converted underscore IP will be equal to check IP, which is our function that we coded in the previous lecture. And we need to check the IP address from the target, which is our parameter inside of the function. Okay, and now we will print, just so we know what we're doing. We're going to print, first of all, new line character, which is \n plus, and let's make some type of a smiley right here, which will look something like this. So, and let's print scanning target. We also want to specify which target are we scanning in case there are multiple ones. So we'll specify the string of the target, which will be either the domain name or the IP address. If we specify plus the string of the converted IP, it will only specify the IP address since it will already be converted from the domain name. But we don't want that. We want to specify plus the string of target, which will be the names that the user specified to the program. And then we need to copy this part from below, which is for port in range. scan each and every port. Let's copy this. We no longer need it right here. We can delete it from here. And we can move it inside of our scan function. So right here. Let me just tab this properly, and we're going to change a few things if we need. So for port in range 75 to 85, we can change that right away, for example, from port 1 to port 100, and you can keep this number as low or as high as you want. Just for the purposes of this tutorial, we're going to leave it on only scanning 100 ports, since most of the ports that we want to see whether they're open or closed will be in the first 100 ports, okay? And then we will call the scan port function onto the port number and also onto the converted IP, which we converted in the first line of our function. Okay, so everything makes sense. Now, another thing that we need to change down here, since we specified if comma in targets, that means that the actual user specified multiple targets to scan, but what if they specify only one target? Well then, nothing of this will get executed, and we will not really scan any target throughout our program. It will simply just exit the program without scanning the target. So we need to add an else statement right here. So if comma in targets, else, we want to scan the targets. Simple as that, because in this case, the targets will be just one IP address or one domain name. Then it will jump from that function to the scan function, which will convert that IP address, and it will perform the scan port function onto the first 100 ports. Okay, so everything makes sense. Now let's see whether we have an error inside of our program or if everything works perfectly. Okay, so let's see how we can run it. Let's open up our terminal and navigate. And first I will enlarge this so we can see everything. And we need to navigate to our PyCharm directory. It will usually be in the /root directory. So here it is, PyCharm projects. I will cd to that directory, type ls. We have the test directory, which we created once we installed the PyCharm, and we have our port scanner directory, or our port scanner project. So let's change the directory to the port scanner, type ls once again, and here is our port scanner.py. I will clear the screen and I will run the program. First of all, let's try it with one target. So let's switch it up a little bit. I will use my actual router IP address in order to perform the test of this program. So I will type 192.168.1.1. Press here enter, and you will see it will perform the scan really fast because my router is close to me. Therefore, we can see most of the ports are closed. We have the port 22 open, port 23 open. Let's see which ones are also open. Port 53 open for the DNS and port 80 open. All the other ports are closed, okay? So, right away, we can notice that this is not really that good to look at. We don't really want to print the closed ports as there is too much happening right here, especially if you scan more than 100 ports, it will be really hard to find all of the open ones. So let's see what we can do inside of our program in order to print only the open ports. Okay, so right here, whoops, we need to go right here inside our code. And in the scan port function is our print statements for the port open and port closed. So what we can do is instead of printing port is closed, we can delete this. And we can simply specify pass. Now what this will do is it will not perform anything, it will not print any statements, it will simply just pass in case the port is closed. Okay, simple as that. Let's test it once again. Python 3 port scanner.py, specify the IP address of my router once again, and this is a lot better. We can see scanning target and then the actual IP address of my router and then which ports are open. And it is the exact same 4 ports that we saw before. Let's try another target. Let's specify actually 2 targets now. If I run the program, and for this test you can specify the same target as I will, which will be an actual domain name, which is called testphp.vulnweb.com. Okay, So let's specify this target, and also you can specify any other random IP address or domain name if you want. In this case, I will specify once again my router. So we have a mixture of the domain name and the IP address, so we can see whether this will work properly. If I press enter, it will first start off with this domain name right here, and it will scan for the open ports, and then it will proceed to the IP address of my router and scan the open ports for that router as well. So we can see on the first link it found 4 ports open, port 21, 22, 53 and 80, and on my router the same 4 ports as before. So our program works correctly. We're almost close to finishing our program, but there is one more thing that we actually want to do. We want to also print which service is running on an open port. For example, let's say we want to discover whether port 80 is running Apache 2 or some other version of a web server. Well, we can do that by simply grabbing the banner on an open port. And more about that in the next lecture. For now on, we are glad that we can scan multiple targets, whether they are specified as a domain name or as an IP address. We can split them by comma. We can also scan one target if we want, and we also print only open ports as we are not really interested in the closed ports. Okay, so thank you for watching this lecture, and I will see you in the next one. Bye. Welcome back everybody, and let's finally finish our port scanner. As I mentioned in the previous video, we're only left to do one small thing before our port scanner is complete and ready to use. And that is to perform the banner grabbing on the open ports to discover which services and which softwares are running on those open ports, which can give us even more detail and information that we can use in our future attack. Okay, so what we need to do is, let's first of all think how we can actually grab the banner from an open port. Well, logically, we need to connect to that port, we need to try to receive something from that open port, and then read that information that we received from that port. So we already performed half of that job. We connect to that port right here at this line. So all we're left to do after it is check whether that port retrieves some information or sends some information back to us once we connect. Okay, so how can we do that? Well, right after the connect function, we can try to retrieve the information. We're going to use a specific function to do that, and we will store the result of that function inside of a variable which we will name banner. So banner will be equal to the function which will be called getBanner, and that function will take as a parameter the socket object. So we're pasting our socket object inside of this function so we can use it inside of it, and then we will retrieve the actual banner if we manage to get it to the banner variable. Alright, so let's first of all code that function. We can do it right here between the scan port and check IP function, and we will call it, as we already said, getBanner. This function will take the socket object as a parameter which we already pasted inside of our scan port function, and all we need to return from this is we need to return the socket object and then .receive, which is the function that receives the data from this open port. We can also specify inside of the brackets which amount of bytes we want to receive, and usually this number is specified as 1024 bytes, as we don't really need more in order to get and print the banner. Okay, so this is the entire function, the entire getBanner function. Now we need to perform some modifications right here inside of our program. So we have the function right here, and we try right here to store the banner inside of this variable. Okay, now if we do manage to store it, we're going to print port, and then the string of the port is open. But let's change it up so it looks a little bit better. So we're going to delete all of this and print the exact same thing, just with the banner attached. So we're going to print something like this. Let's add the plus sign, which means that the port is open. So open port, and then space. We will add the string of the port number that we are scanning. So plus the string of port. And then the next thing we want to do is plus, and we want to add the banner. Let's separate it with 2 dots, and then add or concat the string from the banner to our open port number. So we are going to leave it like this. Let me just see. Another thing that we need to add is another except statement right here. So except in case we cannot get the banner, we're only going to print open port, and we're not going to print any type of banner as we didn't really manage to retrieve it. So open port plus the string of port, and that is all we need to do right here. Now let's see whether this will work. If we open the terminal right here, enlarge the letters so we can see everything, and navigate to PyCharm projects and then port scanner. Then we try to run the port scanner and specify the same two websites as in the previous video, so testphp.oneweb.com. Let's first of all try with this one. It will scan the target, and we can see right here we do manage to retrieve some of the banners from two different open ports. So here it is, we got the banner for the open port 21, and now we know that the version of the software running on the open port 21, which is the FTP port, is ProFTPD 1.3.3e server. And what we can do with this information, we can simply just copy this, paste it inside of a Google, and see whether there is any type of exploit for this specific version of the FTP server. We can also perform the same thing for the SSH, which is on port 22. We see that the version is SSH 2.1, OpenSSH 5.3 P1 Debian Ubuntu. Then we can copy this and try to find it on Google and try to find some vulnerabilities for this version on Google. Simple as that. But let's make our actual output a little bit prettier. We don't really want it to print this B and then the apostrophe, and we also don't want it to print the /r or the \r\n, which simply just stand for the new line character. Okay, so let's see how we can get rid of that. Well, in the part where we are printing the banner, if we take a look at our output, we can see that the banner output starts with B and then apostrophe. That is because we haven't really decoded our banner. Once it actually receives the message or receives these 1024 bytes, those 1024 bytes will be encoded by default. In order for us to remove that B and the apostrophe, we can simply just type banner.decode, which is a function which will remove that, and we also want to strip the new line character. So how we can do that? Well, we can add another function to this banner, which is .strip, and right here we can specify \n. For example, let's see whether this worked. If I go right here and type same website, testphp.oneweb.com. Here it is. Now we got the prettier output. If you compare this one with this one, you will notice we no longer get this B apostrophe and this \r and \n. Alright, so great. Our port scanner works. Let's also test it to see whether it works on multiple targets. So I will clear the screen, run my port scanner, specify, for example, 3 targets, which one of them will be this one, which we used in the first lectures of our port scanner. Then we can use the IP address of my router, and then we can use the same testphp.oneweb.com. It will go and scan one by one. First of all, it will start with this IP address right here. If it manages to find open ports, it will print them out. If it also manages to grab the banner, it will also print that out. It will also print the banner out as well next to the open port. Then it will proceed to the next 2 targets and perform the exact same task on both of them. Now you might notice that some targets will go slower in scanning and some targets will go faster, and that is pretty much normal. Keep in mind that this part right here, which is the socket.setTimeout, is crucial in order to get more or less accurate scan. If we simply just remove this line, then some actual targets might be scanning for hours depending on the distance and the open ports that they have and also the services that they are running. Sometimes it might take longer to connect to those ports and so on and so on. Therefore, it is always good to set a timeout so you don't have to wait an entire day for your scan to finish. But by lowering this timeout, you will also lose the accuracy of your scan. For example, let's say we have a port that takes 1 second to connect to, and you set the timeout 0.5 seconds. Well then, after 0.5 seconds, it will determine that this port is closed even though it is not, it just takes longer to connect to. Therefore, you will lose the accuracy and you will not know that that port is open. So this part right here, which is the timeout, is completely up to you. You can change it to whichever time you want. Let's go back to our scan and we can see all 3 scans have finished. On the first target, we only found 1 open port. We didn't manage to retrieve any banner for it. On my router, we found 4 open ports and port 22 sent the banner back to us, and now we know which version of software it is running. And the target number 3, we already scanned and we got the exact same result. Okay, so our port scanner is complete. It can scan multiple targets, it retrieves the banners, and now we are ready to use it for our penetration testing. Okay, so in the next video, we're going to go really fast over this code so we can explain it once again for those of you that have some inconvenience, or if there is something that you do not understand, I will simply just go fast through that code, and then we're going to see how we can also import our port scanner into another Python program if we want to. After that video, we're going to proceed to our next project. Okay, so thank you for watching this video and I will see you in the next one. Bye! Welcome back everyone, and this is the last video to our port scanner project. Right now what we're going to do is we're going to first of all recap what we did inside of this program. So we're just going to go through the program code real fast and explain what everything is doing once again. And then I will show you how you can use this program and import it inside of another program so you can use it. Alright, so first of all, let's navigate all the way down to the beginning of the program. Here, as you can see, we prompt the user to input a target or multiple targets. We then check whether they specified 1 target or multiple targets. If we find comma inside of this variable, that means they specified multiple targets. Therefore, we will split all of those targets, and for each and every IP address inside of this variable, we will perform the scanning of that IP address. In any other case, that means if we didn't find comma, that means they only specified 1 target. Therefore, we're going to perform the scan function onto the targets variable, as it is only storing 1 IP address or 1 domain name. Okay? Then once we navigate to the scan function, here we first take the converted IP variable and then we perform the check IP function onto the specified target. If the specified target is simply IP address, we will return that IP address and it will be stored inside of the converted IP. In case the target is an actual domain name, therefore we're going to perform this socket getHostByName method, which allows us to convert the domain name into an IP address. Okay? Right after we convert the IP address, we scan for 100 ports. Now this number, keep in mind, can be changed. For example, you can scan for first 500 ports if you'd like. It doesn't have to be 100. This is a number that you can change. Now another thing that you might want to implement in this program if you want, is you can also prompt the user for how many ports they want to scan. How we would do that? Well, we will simply do that by specifying something like this. You go to the beginning of the program and there you can simply type port num. Let's say we call the variable like that, and then input, enter number of ports that you want to scan. Then the user would enter the number of ports. Oops, let's not leave this to be capital. Let's leave it like this. So enter number of ports that you want to scan. Then you would take this actual variable and you will also paste it into the scan function. Once you do that, if you go back to the scan function, right here, you would simply have something like port num as a parameter, and then you would have for port in range 1 through port num. So you wouldn't have 500, you would have something like port num. So simple as that. But we're not going to leave it like this. Let's just leave it as the way it was before. This is just something that you can implement and leave it in the program if you want. In this case, we are not going to use that since it is not necessary. We simply just always want to scan for first 500 ports. So I will delete this. Also keep in mind, if you leave that option, you also need to specify the port number inside of this line right here and also inside of this line right here as a second parameter to the function. Okay? So once we get to this for loop, we scan for each and every port between the range of 1 and 500, and we do that by using the scan port function. So let's go to the scan port function, and this is the main part of the program. Here we create a socket object, we set the timeout so we don't actually waste too much of our time trying to figure out whether a port is closed or open. Keep in mind that the accuracy of the scan will depend on the amount of the timeout that you set. The lower the timeout, the lesser the accuracy, the higher the timeout, the bigger the accuracy. Okay, so then we perform the connect function onto the target IP address and the port number. Right after it, if we manage to connect, we will simply just try to get banner and figure out which software is the target running on that specific open port. If we don't manage to get the banner, we will simply just print open port without the banner, and if we do manage to get it, we will print open port, then the port number, and we will attach the banner right after the two dots. Okay? In any other case, if we don't manage to connect, we will simply just pass and not print anything because we are not really interested in printing which ports are closed. We're only interested in printing the open ports. Okay, so this is basically the whole idea of this port scanner project. And now let's see how we can actually use this program and import it into another program. Okay, so how can we do that? Well, first of all, what we need to do is we need to create another file. So I'm just going to go right click on the port scanner, then go to the new and then Python file, and let's call this file ipscan.py. It will automatically add it right here. So you will have two tabs, one for the port scanner and one for the IP scan. And now we want to import this program. Now, one thing before you actually do that is you need to make sure that both of these files are in the same directory. In my case, they are both in the port scanner project, therefore they are in the same directory, so I can proceed. Now, the next thing that we need to take a look at is the name of our port scanner, so it is named portscanner.py. Now, in order to actually import this file into another file in the same directory, we simply just type the command import and then the name of the program that we want to import. In our case, it is port scanner. So let's type it right here, port scanner, and you will see that PyCharm already recognizes it. Therefore, we successfully managed to import our port scanner program. Now, how can we perform the same task that we did right here, just without typing all of this code? Well, we can simply just call these functions from our second program and use them independently. Okay, so the use of this importing is basically if anyone else wants to use our port scanner, they can simply just import it and use the functions from that program into their own program. So what we're going to specify right here first is the IP address to, for example, be testphp.voneweb.com. This is the domain name that we used to test with our port scanner before, so nothing new right here. And all we need to do to actually run this port scanner inside of a different program is to call the scan function. Now, at first you might be asking, well, why are we calling the scan function? Well, basically you will notice that by calling this scan function, all of the other functions get called as well. For example, inside of the scan function, we first call the check IP function in order to check for the IP address. Then we call the scan port function, which will scan each and every port that we specify inside of this for loop. And inside of the scan port function, the get banner function gets called in order to print the banner. So we don't need to call specifically all of these functions. We can simply just call the scan function. Okay, so how can we do that? Well, in order to call a function from a different program, we first of all need to specify the program name. Just the same way that you would specify a method from a different library. For example, right here, we used socket library and we called a method or a function, and we called a function from that specific library, but before we had to specify the library name. Same way goes here. We first need to specify port scanner and then dot and then scan. You remember that the scan function takes one argument, which will be the target, as the PyCharm already tells us right here, and our target will be the IP address. And believe it or not, but this is the entire program. Just by using these 3 lines, we can perform the same thing that we did inside of our port scanner project. So this is the power of importing libraries. You can see that anyone who wants to use this can simply just write 3 lines and they will perform the same task that we performed by coding the entire port scanner. But there is another thing that we need to take a look at before we actually try to run the IP scan. You might notice this part right here. Well, we don't really want to run this since, first of all, we're calling this scan function already inside of our IP scan program. Therefore, we don't really want to call it twice. And we would actually call it because by importing the port scanner into our IP scan, we're also calling this part of the code. Importing a library simply means that we're going to paste the entire port scanner code into our IP scan function. Therefore, this part of the code will also get ran. So how can we make sure that this part of the code doesn't get ran? Well, simply we can type if underscore underscore name underscore underscore equals and then open double quotes underscore underscore main underscore underscore. If this is equal to main, then we're going to run this part of code. So let's tab all of these lines in, so they belong to this if statement. And now this part of program will only get ran if we run the port scanner. This line basically means that the actual Python will recognize whether this program is being ran as a main program or it is being imported into a different program and ran from there. In case it is being imported in a different program, like in this case right here, then it will not run this part of the code. If it is not imported into a different program, and if we simply just try to run the port scanner itself, then this part of the code will actually run. And that is the meaning of this line right here. You can simply just remember this as, if this is the main program, then run this part of the code. Okay, so right now let's test our ipscan.py. Let's open the terminal and let's type python 3 ipscan.py. You can see it is scanning the target. It already found the 2 ports open, and it will scan for first 500 ports as we specified and change the number from 100 to 500. You can see we are also getting some banners from these open ports. We got open port 106, open port 110, 143. We can see here is a long banner from that port. Not really sure what this is. We also discover another open port, which is port 465, and therefore our program closes as it reached the 500 ports number. Okay, so it actually does work. Now another thing that you should keep in mind is that you will need to actually code this part of the code into this IP scan because, for example, if a user specifies comma and then an IP address, this will not work because we do not have this part and this if statement right here. Therefore, it will not be able to scan because of this comma right here. So if you want to be able to scan multiple targets from your IP scan program, make sure that you implement this if statement into the IP scan. But we're not going to do that at the moment. There is no need for that. We already did that in the port scanner program, and I will leave that up to you. Okay, so with this, we actually finish our first project, which will be the port scanner. And in the next project, we're going to take a look at how we can create the vulnerability scanner, which will be based on this port scanner that we just created. So make sure not to delete this program as we're going to need it. You also know that you will have all of these actual programs in the resources at the end of each project. Okay, so you can simply just download them if you don't want to code them. I hope you enjoyed this lecture, and I will see you in the vulnerability scanner project. Take care and bye. Welcome everybody to our second project of this course, which would be a vulnerability scanner. Alright, so what we did by now is we created our port scanner, which managed to scan multiple targets as well as one target, and also discover which ports were open and closed, and we also managed to discover some of the softwares running on those open ports. Alright, right now we want to advance our game and create a vulnerability scanner which will be able to detect which of those softwares are potentially vulnerable to some type of the attack. So there are a few approaches that we can do in order to create this. I picked one which is going to be based on our port scanner, meaning that we are first going to import our port scanner, we're going to scan for the open ports, then we're going to create a list of vulnerable softwares in a txt file, which then we're going to also import into our program, and then we're going to compare the softwares on the open ports with the softwares named in the list or in our txt file, and if they do match, that means that we discovered a vulnerable software which can be exploited. Alright? Now you can actually download some of these vulnerable softwares list over the internet, or for the purposes of this tutorial you can simply just create a small list of a few softwares like I will in order to test our program. But before we do any of that, let us open up our PyCharm and create our new project. Alright, so I will open up my PyCharm by going here and typing PyCharm. Here it is, it loaded fully, and by default it will open up our previous project, which will be the port scanner project, but we do not want to continue coding inside of that project, we want to create a new one, and then we are going to copy paste the port scanner into that new project. Alright, so let's wait for it to reopen all of the files from the port scanner project. Okay, so here it is. Now, let's go onto the file right here, click on the new project. Under the create new project, in the location, we can create a name for our new project, which would be vulnerability, or let's just type vuln scanner, it doesn't really matter, you can call it anything you want, and then click on create. It will ask you whether you want to open the project inside of this window, or whether you want to create a new window for it. We can simply just create this window, and it will open up the new project that we just created. Alright, so here it is, it's creating all the dependencies needed. And right now what we're going to do, we're going to open up our terminal. We are going to navigate to our port scanner project using our terminal, and then we'll copy our port scanner to the vulnerability scanner. Right, so let's go to the PyCharm projects. If I type ls, here are both of these. Then we want to navigate to the port scanner, type ls once again, and we want to copy the portscanner.py into the vulnerability scanner directory. Alright, so cp portscanner.py to the root, PyCharm, and then vulnerability scanner. Press enter, and in just a few seconds we should see our port scanner right here. Okay, so here it is. Let's open it up. And here is our program. Now, as I mentioned previously, we're going to base our vulnerability scanner onto this port scanner right here, but we're not going to code it right in this program. We're simply just going to import our port scanner, as I showed you in the previous video how you can do that, and we're going to perform some small modifications to this program right here. For example, we want to make this program a class. So we're going to delete some of the functions right here, we're going to modify this part of the program, and we're going to create this to be one giant class, alright? But more about that in the next tutorial. For now on, we just simply copy this, we created our new project, and in the next video we're ready to start coding our vulnerability scanner, alright? So, see you there and take care. Bye. Welcome back everybody. So for now we haven't really done anything yet, but we did import our port scanner, and now we are ready to start coding the main part of the program. So let's go to the vulnerability scanner right here, right click on it, click on the new, and click on Python file. So all of this stuff we already learned, we know how to do it, and let's create a program which will be called vulscan.py. Now first thing that we want to do is of course to import our port scanner, which makes sure that it is in the same directory. That is important, and that is actually going to be the only library that we are going to need, since these two libraries, which are going to be the socket library and the IPY library, are already imported inside of this port scanner program. Alright, now you might notice once again that this IPY is actually red underlined, which means that this library does not exist inside of this virtual environment, and we already talked about this before. You need to actually pip3 install it inside of this virtual environment, so let's do that right away using our terminal. Make sure that you're using terminal inside of the PyCharm, and simply just type pip3 install IPY. It will install a library for you, and as soon as it is finished, you should no longer have this red underlined. Alright, so let's see. Here it is gone now, and now we have all of the libraries needed to complete our project. Alright, so let's go back to our main part of the program. We imported our port scanner, and now let's think about all of the things that we need in order to complete this project. So first of all, of course, we need the target that we are going to scan, so we want to prompt the user of this program for the target's IP address. So let's call it target's IP equals input, and we're going to actually ask the user for the input of this. So let's type it like this, and then we can add a star sign, enter target to scan for vulnerable open ports. Okay, so this will be the target's IP. Once again, we also want to make sure that this can be both IP address and the actual domain name, but we don't need to worry about that, as that part of the code is already located inside of our port scanner that we imported. So no need to code it once again. Let's just go to the next line, and also let's ask for the user for the number of ports that they want to scan. Now we didn't use it in our port scanner, so why not use it right here? Let's say they want to scan 100 ports and a different user wants to scan 200 ports. Let's add that as an available option as well. So port number will be equal to the input, and in the second line we prompt the user for the amount of ports you want to scan. And let's also notify them inside of the brackets that 500 will mean first 500 ports. Okay, so in case they get confused, they know what they need to specify. Alright, now another important thing that we need to do about this line is we need to make sure that this port number is an integer value. For example, if the user specifies number 100, it will be stored inside of this port number, but it will be stored as a string and not as an integer. Therefore, we need to wrap this entire part inside of an integer function, and this integer function simply just converts whatever is inside of the brackets into an integer value. Keep in mind that you will get an error in case the actual user of this program specifies a string. For example, they type the word tree. Well, that word will not get converted to an integer because that is not possible. Therefore, this will only work if the user specifies the actual number, which should be the case, as we are indeed asking for a number. Therefore, we want to convert it to integer so our program can continue executing. Alright, so now that we got these two things out of the way, there is a third and last thing that we need to ask the user before we actually start running the main part of the program, and that is going to be the actual file from which we're going to read vulnerable softwares. So for this program to run, we need a file. As I mentioned at the beginning of this section, we need a file that is going to store vulnerable software names that then we're going to compare with the softwares running on open ports. So we're going to call that, for example, vul_file, and it will be equal to the input let's add the double quotes. So to the input, and then we prompt to user enter path to the file with vulnerable softwares. Okay, so now that we finished everything, these are three things that we need in order to run this program. Let's print also the new line character. So right after this, we can have a little bit better view. And now we want to use the port scanner onto our program. Alright, so we're simply just going to call the function port scanner.scan onto the target's IP. Okay, now, if you think about this a little bit, you will notice that this will not actually work. Now, why this will not work? Well, there are a few problems with our port scanner, not with the port scanner itself, but with the way that we imported it and that we are going to use it inside of our vulnerability scanner. So first of all, we got a problem with this port number variable. We cannot really paste it into our scan function, as our scan function only takes one parameter. So that is the first problem, as we don't really have a way to actually tell the port scanner that we want to use this exact amount of ports. So that is the part that we also need to edit inside of our port scanner. Now another thing that we want to do is we want to convert this entire actual port scanner into a class. And we also want to get rid of some of the functions that we don't need. And also we want to get rid of this part of the program. Since there is a lot to do with this port scanner, we're going to leave that for the next tutorial. So in the next tutorial, we're going to cover this port scanner and convert it to the best possible way for us to use it inside of our vulnerability scanner. And then we're going to continue from there. Alright, so for now, we simply just prompted the user for the needed things. And in the next video, we're going to cover the port scanner and how we can convert it the best way possible. See you there and take care. Bye. Hello everybody and welcome to this tutorial, and right now let's cover the port scanner conversion to a class. Alright, so anyone who's actually covered and learned Python before knows what classes are and knows why they are important, and in this case, in our case, we want to make sure that we convert it to class for the better usage inside of this vulnerability scanner project. Alright, so first thing that we're going to do is we're going to create the class at the top of this program. We're going to create it with the keyword class, and then we're going to call it, let's say, port scan. Open and close brackets and add 2 dots, and this is how we can create a class. Now, all of these functions that we have below, we want to make sure that they belong to our port scan class. So what we can do is we can tab each and every line. So let's do it one by one. Like this, and you will see that some of these actual keywords will start changing colors as they start belonging to our port scan class. Alright, so let's do it like this. All of it should be tabbed once, so let's go like this, and the scan port at the end. Okay, so here it is. Now, this part of the program, you might be asking what we're going to do with this. Well, in this case, we don't need it, so we can simply just delete that. All we need are our class with these functions right here. Let me just create space between each of these functions so we can see each and every one of them a little bit better. And now let's see what we need to do in order to get this to work. Well, first of all, we are missing a function that every class needs, and that is the init function. This init function will be coded at the top of the class, so right below the initiation of the class itself, we're going to type def __ init __. Alright, and you will notice that by default, if I open and close brackets, it will add this self argument as a parameter to this init function or init method right here. And this self argument basically means that it is belonging to this class, and what we're going to define inside of this init method is all of the stuff, well, all of the parameters that are going to define the object to our class. For example, we want to define the target parameter and the port number parameter. That is an actual attribute to our class which defines our object. Alright? So next to this self argument, we need to define those 2 attributes. So the first one we can call target, and the second one, which is the new one, will be called port _ number. Alright, so simple as that. And in order to define them inside of the init function, we simply just type self.target will be equal to target, and self.port number will be equal to port number. And this is just a Python way to actually define them, so nothing really important there. Let me just delete this empty space. And now that we have our init function, we need to add this self argument or self parameter to each and every function that belongs to this class. So we're simply just going to go right here and type self. We're also going to type self right here. Self right here, and self right here. And another very important thing that we should consider is that we don't need any of these other parameters outside of the self parameter. And why is that? Well, once you define those attributes that we need inside of this init method right here, we can access these variables throughout each and every function in our class. So we don't need to paste them as parameters. Let us just delete everything but the self parameter from each and every class. And right here as well. Make sure you do not delete it from the init methods. So let's leave it like this. So now that we fixed all of the methods, let's restructure our program a little bit. So I will start off with the scan port function. Alright, so what we're going to do with this scan port function, besides it doing the usual stuff that it did inside of our port scanner project, we're going to add the converted IP into the scan port function instead of the scan function. So we're going to delete it from the scan function first. Let's go right here. We also are not interested into printing anymore, since printing we're going to do in the main program, which is going to be the vulnerability scanner. So our scan function will be left with just these two lines of code, while the conversion of the IP address will be moved right here into the scan port function. So we're going to call the check IP function. And you will notice right away that some of the stuff inside of our class is actually red underlined. And by some of the stuff I mean a lot of things, such as for example this check IP is underlined, these two variables are underlined, this get banner is underlined, the port is underlined. So all of this stuff are underlined, which means that they are not recognized by the PyCharm. Well, why is that? Let's start off first with the functions themselves as to why they are underlined. Once you create a class, you need to actually rename those functions when you call them inside of the class. You need to add the self argument before. So for example, if I type self.checkIP, you will notice that it will no longer be a red underlined, and this will get recognized by the PyCharm. This is just a way to call different methods from the class itself, so the class can recognize that this check IP belongs to its own methods, and therefore it knows which actual method to call. Same goes with this getBanner function right here, which we can simply just add self.getBanner, and it will stop being red underline. Let's see whether we have another function which is red underline. Here it is, scanPort. If I simply just type self.scanPort, we can see it works successfully. Now, but what are we going to do with these actual variables, which are red underlined? Well, first of all, we don't really need this IP address variable anymore, as we're actually getting the IP address from our main part of the program, which is going to be the target's IP variable right here. And then we're going to paste it into our class, which will then get stored inside of this self.target variable, which then we can use throughout our class. So let's change it everywhere we can. First of all, we're going to change it in the check IP method. So we're no longer checking the IP from the IP, we're checking the IPs from the self.target, and make sure that throughout of this class you also use the self argument when specifying the variable name. So we're trying the IP function from self.target, and in case it works, we're returning self.target. In case it doesn't work, we want to return the getHostByName from the self.target. Once again, keep in mind that this will store the IP address from our target machine. Same goes right here to the scan port. We don't really need this converted IP anymore. And why don't we need it? Well, we don't need it because, as you can see, the scan port function doesn't take the IP address as a parameter anymore. Therefore, this is red underlined, so we can simply delete it. But what with this port number? Well, we actually need to send this port as a parameter because we are inside of this for loop. Therefore, this port will change through each iteration. And we need to specify to this method right here which iteration is it currently at. So we need to send the port as an argument. Therefore, we're going to go to the scan port, and next to the self, we're going to add port as a parameter, and you will see right here at these three spots, the red underline will go away, as this port now exists in this program. And the last part, which is red underlined, is this IP address right here. Once again, we don't really need this IP address anymore. We have self.target, and right here, since at the beginning of this try statement we converted the IP, we don't need to specify self.target right here. We can specify converted IP. Alright, since this will be the IP address, whether the target was specified as a domain or simply as an IP address. Alright? Another thing that we want to make sure is that we don't have unnecessary functions that can be put inside of a different functions. For example, this get banner can also be put inside of this scan port function. Therefore, we don't really need this method right here. So we can simply just delete the get banner. And we can put it right here. As you will see, this will get flagged as get banner doesn't exist anymore. Therefore, instead of trying to call this function, what we're going to do is we're going to write the get banner function code instead right here. So sock.receive. We want to receive 1024 bytes. And we're simply just using the sock object that we created right here. So no worries about that. We don't need to name it anything differently. We also want to decode the response. And the reason why we're decoding the response is so we don't really have to do it later on right here. So once we decode the response, we then want to strip it from any unnecessary characters, such as for example \n, and also we want to strip it from \r. And the reason why we are performing this stripping part is because, especially in this program right here in our vulnerability scanner, it is important to strip everything that we don't need from the response, as this banner variable will store the most important and crucial part to our vulnerability scanner. As inside of this program, we're going to compare this banner variable with the actual content from this vulnerability file in order if they match. So for example, if we have the same banner in a vulnerability file and the same banner gets retrieved into this variable, and imagine that we do not strip these actual characters from it, well, our program will not really find a match, as they will be different only by this character. So that's why we're stripping it, as the new line character is not important to us. Alright? So simple as that. The next thing we actually don't need is these print statements right here. We needed them inside of our port scanner project, but we don't need them anymore, as we are not really interested in printing which ports are closed and which ports are open, since this is not a port scanner. But however, there is another problem that will occur, and that is that this banner can only store one banner at a time. But we need to retrieve multiple banners if we find multiple ports open on the targets, and if we also manage to retrieve multiple banners from those open ports. So we will need to store multiple banners and not just one. So how can we fix that? Well, we can actually easily fix that. We can simply just add a list, which will be at the beginning of our class. Right here we're going to call it banners, and in order to define a list we specify these square brackets right here. By specifying open and close square brackets, we initiate that this banners list will be empty for now, and then every time we actually manage to retrieve the banner right here with this line, we can then right after it below append the actual banner to the banners list, just like this. And you will notice that this banners is red underlined. That means that we need to add the self.banners argument right here, and everything will work correctly. And in case we don't manage to retrieve the banner, we're simply just going to pass for now. Alright? And at the end, we can simply just close the connection with sock.close. So simple as that. Let me see if everything is correct for now. Everything seems to be good. Our get check IP function is good. Our scan is good. But don't worry. There is another thing that we actually have to do, which is going to be to create another list, which is going to be the open ports list. Now you might be asking, why are we actually doing this? And this is more easily showed than explained, but I will try to explain it anyway right now, and once we run the program you will get it why we need this open ports list. For now on, let me just try to explain it. Well, once we actually created this class right here with these three methods, you notice that we also had to create this banners list right here in order to store multiple banners. Once we actually get to printing those banners and open ports into our vulnerability scanner, we want to make sure that each open port will match to each banner. And since we removed all of the print statements, we cannot really print open port one by one. We have to store all of the open ports somewhere and all of the banners somewhere, and then we have to print them, each element one by one. That's why we also need the open port list that we created right here. And after each time we manage to connect to a port, we will add that port to the open ports list. So self.openPorts, and then